Hello and welcome to session 14, where we're going to be going through sequences and series and some exam questions. So I'm going to share my screen and let me know if you can't see it in a second. All right, hopefully now it should be visible. All right, so today, like I said, we're looking at sequences and series. If you have not joined any of our sessions, I'm Ashley from Miss IB Maths. I'm an IB teacher, tutor, and IB examiner, working in collaboration with Exam Dojo for these bootcamp sessions. We'll be starting with a warm-up question, going through some of the theory for sequences and series, and then looking at some exam past paper questions and tips and tricks, and then going through the mark schemes and just doing a bit of showing you what's going on in the mark schemes, what to look out for, and what to make sure that you do and to make sure that you write. All right, so here we have a warm-up question. So can you answer this in the chat? This just means put your answer in the chat if you see that box. So the first question is, what is the common difference for that sequence? And what is the common ratio for that series? Give a couple of seconds for you to answer that in the chat. All right, so the common difference here, we want to think how is this changing, going from one term to the other? It's a common difference, by the way. Let's do that again. It's a common difference if it is a sequence. So these words are important for an arithmetic sequence. So arithmetic, we have a common difference, and for a common ratio, that's for geometric. So just a note in these words that we have here. All right, so to get from term to term in this one, from 6 to 3, we are taking away 3. So the common difference, let's say D is minus 3. Make sure you don't forget that minus, because you're minusing 3. And then common ratio for this one, how are we getting from one term to the next? You could say we're dividing by 2. That's true, we are dividing by 2, but with a ratio, we only want a multiplier. So the same thing as saying dividing by 2 is saying multiplying by a half. So we need to say that our common ratio is a half. We don't say divided by 2 for a ratio. All right, just to start with what you have in the formula booklet, these are your formulas. A lot of this topic is just substituting into formulas, using the clues that they give you, and then substituting into these formulas. So you have to find a term in an arithmetic sequence, and then the sum of all values in an arithmetic sequence. So this would be for, if we have it written like this, 2, 4, 6, 8, 10. That is a sequence. And if we have 2 plus 4 plus 6 plus 8 plus 10, that's an arithmetic series. So that's finding the sum. So this is a sequence when it's commas, separated by commas. And this is a series when it's separated by plus signs. So this is going to result in a formula. This is going to result in a number. So there's formulas there. This little formula here, when it says comma and then that, let me just zoom in on that. There we go. This one here is useful. It's like a shortcut when you have the first term and the last term. First term, U1, and the last term of the sequence. When you know that, you can just use this formula. So that's quite nice, because you don't need to know the value of D for that. And that can sometimes be useful. So first term and last term, just a little shortcut. Then we have let's do it in green, geometric sequences. So the nth term of a geometric sequence, and then the sum of a finite. Important to note, finite. Obviously, we can't do the sum. Well, we can, but for now, with the sequence, it's the sum of a finite geometric sequence. So when you know the end number, you can use this formula. There is also the sum of an infinite geometric sequence. Right, so infinite, then it converges. So for converging series, we can find the sum of the infinite geometric series sequence. And that's only when the value of your common ratio is less than 1. So another way that we can write this is when r is between -1 and 1. Like the absolute value is less than 1. So we could say it's just got to be between -1 and 1. When that is the case, we can use the sum to infinity. So these are our very useful formulas, and we're going to be working with those today. So just to go through those a bit by topic, these are for our arithmetic. Linear ones when you're adding or subtracting. So the first thing we start with is A, often called U1, your first term, plus the number of terms. So if we have like 2, 4, 6, 8, this is the first, this is the second, this is the third, and this is the fourth. So if I want n equals 4, that's n and un if you want to put it in a table. If I want the fourth term, n equals 4, I'm going to get 8. So we could see how that would look. Let's see. We are taking u, and we want to get a general term. I'm going to write u1 because that's how it appears in the formula booklet. The names for this we call nth term, general rule, general term. There's all these different words. Let me just zoom out a little bit. General term, general rule, nth term, all of those are meaning for this, just the general thing. So we can find any term in the sequence. All right, so we keep un, and u1 is 2. The first term of our sequence is 2. n minus 1, let's keep general for now. And our common difference is from each one, we multiply by 2. So it's 2. And if we multiply this out, we get 2 plus 2n minus 2, multiplying out those brackets and simplify. That is just 2n, 2 minus 2, so it just leaves us with 2n. And that is our general term. un equals 2n. Actually, I don't like that. I'm going to use a box instead. Oh. Didn't want to do that either. I want with this and a box. There we go. Okay, so there we have our general term. With this, we can generate any number in here. So let's say if I want, let's say n equals 4. So I substitute for n equals 4. I say u4 equals, and then I take my formula 2 times 4, which is 8. And indeed, that does work. So I know that my sequence works. So that's how I could generate, say, the 100th term. Let's say I want u of 100. Now, I'm not going to just go 2, 4, 6, 8 all the way until I get to 100 to see what value that is. I can just use my sequence. Obviously, in this one, it's quite nice and easy to see what it's going to be, but in more complicated sequences, it's a very useful formula. So I know that my 100th term is 200. So that's why this formula is useful. And then we also have the sum of the terms, and that uses exactly the same values here. We need, this was the first and the last term, so I actually missed out on that formula. We have Sn equals n over 2 times u1 plus n minus 1d. That was our sum of terms. So if we wanted to do the sum of, let's say, the first 4 terms, we say the sum of the first 4 terms is equal to, and let's just write out the formula because that's good practice. You should always write out the formula first. So then you can just go and insert below. So there are many times when the formula is wrong. So we wanted n equals 4. You can write it on the side as well. N equals 4. What else do I need? U1 equals 2. We had that from before, 2. D equals also 2. So it's quite helpful to write that out before each question, just so you know what you have and what you need to find. All right, so let's just substitute that in. 4 over 2. 2 times U1, which is 2. Brackets are so important here. N minus 1. And that was 4 minus 1 times my common difference, which is 2. Anytime you substitute, put it in brackets. And let's simplify. So we have 4 divided by 2 is 2. 2 times 2 is 4. 4 minus 1 is 3 times 2, so that's 6. So I have 20. And let's just double check. We were doing the sum of the first 4 terms. So that would have been 2 plus 4 plus 6 plus 8. And indeed, 2 plus 4 is 6, plus 6 is 12, plus 8 equals 20. So correct. That's how we can use that one. Then we also have sigma, the Greek letter sigma, and that is for finding the sum also, just like this, finding the sum of values when they give us the general term. They give us the rule that we've got to use. So let's do an example to see what that looks like. All right, so we need to evaluate this guy. It's saying that we take the sum of this formula here. We start with I equals 1, and we go until I equals 5. So this is our starting point where we start, and this is our ending point. Careful, because sometimes it starts at 0. So now we know we're going to have 5 terms because we're going from 1 to 5. So we'll have the values of n equals 1, 2, 3, 4, 5. Except we're using I. If you started at 0, you would have 0, 1, 2, 3, 4, 5. So just basically stop when you get to 5. And we're going to sum them. So we're going to take all of these and add. So let's have a look at what that looks like. Let's start. So we have 2 plus 3. I starting with 1. So 1 minus 1. And we're adding it, we're summing it. That means sum them. And let's go again. 2 plus 3. Our I is now 2. 2 minus 1. And then we're going to keep going. 3 minus 1 plus 4 minus 1 plus. All right, and now we've got to 5. So we stop at 5 because it said go up until you get to n equal or I equals 5. There we go. And now I've just got to solve it. So by substituting the first one, I equals 1, I can generate the first term. So this is my, let's underline it. This over here is my U1. That is sometimes useful in questions. And this is U2. So I can find my common difference if I take U1 minus U2. Sorry, U2 minus U1, I can get my common difference. And then I have everything I need to get anything from the sequence. That comes up quite often as a question. Okay, so we have 1 minus 1 is just 0, so that's just 2. So my U1 is 2. Plus 2 minus 2 is 1, times 3 is 3, so 5. You can see we're going up in 3s here. 3 minus 1 is 2, times 3 is 6, plus 2 is 8. Indeed, we are going up in 3s. Then that's 3 times 3, which is 9, plus 2, which is 11. Then 5 minus 1 is 4, times 3 is 12, plus 2 is 14. So yeah, each time we went up plus 3, plus 3, plus 3, plus 3. So my common difference, U2 minus U1, that's 5 minus 2 is 3. and my u1 was 2. So using even just the first two terms of this, the sigma sum, we can figure out u1 and d from that. So they look scary, but they're actually not so bad. And we should sum it, actually. We need to add it all up. The end result is actually to add it. So you could write it like that. But let's see, we have 2 plus 5 is 7, plus 8 is 15, plus 11 is 26, plus 14 is 14. There we go. All right, now geometric sequences and series. So we have the general term. So let's say that I have 2, 4, 8, 16. Now we are multiplying by something to get to the next term. I have to multiply, not add or subtract. Multiply by something. So again, I have my first term, my u1, times my common ratio, not common difference. So arithmetic had common differences and geometric has common ratios. And then n minus 1. So they all use the same thing. So let's set that up. I want un for this one, a general term. My u1 is 2 times my common ratio, which is also 2. And then n minus 1 we leave like that. Now, it is super, super important that you don't simplify that to 4. I'm going to put a big cross through that. We are not allowed to do that. That's not allowed. Because of this n minus 1 being raised to the power of this 2, that n minus 1 only applies to that 2, not that 2. So we can't combine them. We can't simplify them. Remember BODMAS or BEDMAS or PEMDAS, whichever one, the order of operations, brackets, exponents, division, multiplication, addition, subtraction. Exponents come first, so that goes first with that one. So we can't actually simplify that. We just leave it like that, and then it's fine. Okay, let's practice finding this term. That is 1, 2, 3, 4. Let's pretend we want to find u4 again. Well, I take 2 times 2, just using my formula. My n is 4, 4 minus 1. So let's simplify. 2 times 2 to the power of 3. Well, 2 to the power of 3 is 8. And 2 times 8 is 16. There we go. 16, we got it. It works. And then for the sum, same thing. We take u1, 1 minus the ratio to the power of n, 1 minus r. Be very careful that you get this the right way around when you copy down this formula. And then again, the sum of a geometric series. Let's do an example of that. Okay, so again, we have the sum of this geometric one. We can see it's geometric because it's following the geometric formula. And again, we're starting at 1 and we need to go until 5. So we are going to have 3 times, there's a dot there for times, 2, and we start with 1 minus 1. Put this all in brackets just so we can see. So this is our u1. Plus, we're always plussing, 3 times 2 to the power of 2 minus 1, plus 3 times 2 to the power of 3 minus 1. I'll write it down here. 3 times 2 to the power of 4 minus 1. 3 times 2 to the power of 5 minus 1. And now we've gotten to 5, so we stop. And evaluate, as in we answer. I'm just going to highlight that 5 and that 1. Those are the most important parts. All right, 2 to the power of 0 is just 1, so that's 3. So our first term, u1, is 3. We can find our d by taking u2 ratio, by finding u2 divided by u1, because now we're doing ratios. We're doing timesing and dividing to get to a term, not adding and subtracting. So u2 divided by u1. All right, where were we? in green. No. It's being difficult. Then 2 to the power of 1 is just 2, so that is 6. 2 to the power of 2 is 4 times 3, which is 12. You can see here how we're multiplying by 3. 4 minus 3, 2 to the power of 3, so that's 8 times 3 is 24. And 2 to the power of 4 is 16 times 3, which is 48. So each time we're multiplying by 2. So we can see that there, but let's stick with this because sometimes it's not as easy to see. U2 divided by U1 is 6 divided by 3, which is 2, indeed. So that's a useful fact. And then we add it all up. I'm not going to do it now just because unnecessary step, but imagine that you would add it all up. All right, some exam style questions now. They love to ask it in different ways where you have to use the formulas and your understanding to work it out. Okay, so this is a paper 1 for AASL, so no calculator. The first 3 terms of an arithmetic sequence are U1, the first term, 5 times U1 minus 8, and 3 times U1 plus 8. Okay, so we pretend that's our term 1, our term 2, and our term 3. Now we need to use that to figure out some things. So show that the first term is equal to 4. So we need some kind of relationship between these. So to figure out that U1, I have a relationship that my second term minus my first term is equal to my third term minus my second term. That's one that comes up quite often. So 5U1 minus 8 minus U1. Taking that minus that one is equal to this one minus this one. Like that, minus 5U1, don't forget brackets, minus 8. This is a relationship. That's saying that U2 minus U1 must be equal to U3 minus U2. Because we have to add the same amount to get to the next one. So now we have an equation with just U1, so we can solve. So 5U1 minus U gives us 4U1 minus 8. Here we have 3U1 minus 5U1, so that gives us minus 2. And then 8 plus 8, so that's plus 16. Move over my first term, so I get 6U1 equals 16 plus 8 is 24. And so U1 equals 4. And there we go. I've proved it. Great. U1 equals 4. Very important to note here that when they say show that command term, show that, you cannot use this fact. You cannot substitute immediately that U1 equals 4 into here and then show that it works. You have to pretend like you haven't seen that and end up with it. You can't use it in your working. All right, then prove that the sum of the first n terms of this arithmetic sequence is a square number. So they've given us a hint, even if we don't really understand what the question wants for us or what it means, all these different colors, is that the first n terms of an arithmetic sequence, that's our first clue, we're with arithmetic, not geometric. And we have sum. So the sum, so we write that formula. Let's already start by writing it, and then we'll see what we need to introduce. The sum n over 2, 2U1. There we go. So now we have our formula. Let's see, what do we know? Well, we know U1 is 4. I don't want to write it there because I think my camera is in the way. U1, no, that's too close. Maybe I'll do it there. Okay, u1 equals 4. What is our common difference? We don't know that yet. We don't know the common difference. But we know what u1 is, and we have this relationship here. So I can substitute and find, let's see. So we have wait, let me write it like here. Okay, so our common difference must be 5u1 minus 8. That's our second term minus our u1. That would give us our common difference. Again, taking the second term minus the first term. And we know that u1 is 4. So 5 times 4 minus 8 minus 4. So that's 20 minus 8, which is 12 minus 4, which is 8. So our common difference is 8. So now we have quite a few things to fill in. So let's go ahead with that. N, it's just the first of the sum of the first n terms, so it doesn't matter what n is, it's general. u1 was 4, n is still general, and our d was 8. Now let's multiply out what we have there and simplify. And something about that is going to help us have show that it's a square number. Okay, so we have n over 2, that is 8 plus 8n minus 8. Well, this 8 and that 8 cancel, so we have 8n squared over 2. Simplify that further, that's 4n squared. Okay, that's still not showing that that's a square number. We have n squared is a square number, but when we multiply it by 4, it's not necessarily going to be a square number anymore. So let's see, can we turn this into something that is squared altogether? So if we write this like that, that's 2n times 2n is 4n squared. Well, whatever's in here is going to be a square number because that's squared. So let's say we can test it. N equals 1. So that means we're going to have 2 times 1 squared. So that's just 4. There we go. It works. N equals 2. That's going to be 2 times 2 squared, which is 4. Which is 4 squared, 16. So indeed, because that's going to square every number we have on the outside, doesn't matter what we put in here, it's going to be squared, and that's going to make a square number. So therefore, square number. And it's sufficient to say that that is a square number. Your examiners will know. So let's see, what do we have on the mark scheme? So you have a lot for setting up your equations. So anything that showed you recognize that u2 minus u1 is the same as u3 minus u2. Then we have, just method marks. There's nothing crazy going on here. If you explain the final, if you explain that 4n squared is a square number, then you can get the final A1, but you do have to explain that. So it's easier just to write there. And don't forget to say at the end, you have to conclude it. So the sum of the first n terms is a square number, like I did here. So therefore, a square number. Mine was a bit lazy, but don't forget to conclude your sentence. You don't get a mark for it, but you do need to show it. All right, another one. They're always giving you clues, and you have to use the formula to figure out the clues. Let's go in blue, actually. The seventh term of an arithmetic sequence is 6. So let's set that up. The seventh term, u7, is u1 plus n minus 1. Well, n is 7. 7 minus 1. D equals 6. So already we have u1 plus 6d equals 6. That's already one equation to work with. All right, let's try this one. That's like our first clue we've put in. The sum, so sum in maths means when you add two numbers together, the sum of the 6th term and the 12th term is 24. So sixth term, that's u6, is equal to u1 plus 6 minus 1 times d. We don't know what it's equal to, but we know the sum of them is equal to 24. So let's simplify that. We have u1 plus 5d. And then the 12th term, u12, is u1 plus 12 minus 1d. So we can say u1 plus 11d. So there we have those two, and it says the sum of these two is equal to 24. So the sum of u1 plus 5d, put it in brackets so they're clear, plus u1 plus 11d is equal to 24. And that is our second equation. So you can see where this is going. We have two sets of equations with two unknowns, u1 and d, and we need to solve them simultaneously. So let's just simplify this one quickly. We have 2u1 plus 16d equals 24, and this one was u1 plus 6d equals 6. I'm going to multiply this equation, let's keep in red, by 2, so I get the same coefficients here. So then this is 2u1 plus 12d equals 12, just everything multiplied by 2. Don't forget to multiply everything. And now they have the same coefficient, so we can subtract this one from this one. I should be calling this now equation 3, and this now equation 4. And we're going to do equation 4 minus equation 3. So 2u1 minus 2u1, that's what we needed to get rid of, so that's gone. 16d minus 12d leaves us with 4d. 24 minus 12 leaves us with 12, so d equals 3. And then u1, you can use any equation here. I'm going to take this one. 6 times 3 equals 6. So u1 plus 18 equals 6, and let's minus that. 6 minus 18 is minus 12. So minus 12 plus 18 gives us 6. And there we go. We have our d value and our u1 value. Just double check that that was the question. Indeed, find the first term and the common difference. So they're often going to do this, actually, give you some clues to piece together bits of the formula, and then you have to find, you have to put together your equations to get a set of linear equations and solve them. All right, in the mark scheme, yeah, again, nothing crazy, just method marks. Again, show your formula. You get marks even just for attempt to use a formula. So make sure you write that out to show you know what you're doing. Okay, for a particular arithmetic sequence, again, we have two pieces of information. So you see how they're often giving it like this. U10 equals 14, so let's set that up. U10 equals U1 plus 10 minus 1d is equal to 14. We can simplify. 9d equals 14. So that's one piece of information. So just put it into formulas. That's all you can do before you even really know how to answer the question. S of 25, the sum of 25 is n over 2. So that's 25 over 2 plus 2u1, we don't know, plus 25 minus 1. We're just substituting and seeing where we're going. We don't know d. And simplify. So that gives us 200. So 12.5, 2u1 plus 24d equals 200. And I can just get this on that side. So I can divide 200 by 12.5. 200 divided by 12.5. 16. Okay, so it equals 16. That's nice. So that is our second equation. And again, we're just going to solve them. I'm going to say, let me write that one. I'm going to multiply this one by 2 again to get the coefficients the same. So everything multiplied by 2. So then we get 2u1 plus, that was 9, right? So 18d equals 28. That's now my equation 3 because I've enlarged it. And now I'm going to do equation 3 minus equation 2. So I just show the examiner what I'm doing. So these cancel out. 18d minus 24. Again, just make sure you're good with the direction that you're going, that you do the same thing. So 18 minus 24 is minus 6d. And 28 minus 16 is 12. So d equals minus 2. And then u1 plus, let's do 9 times minus 2, just using this equation here, equals 14. So u1 minus 18 equals 14. Add 18 to the other side, so u1 equals 32. And yeah, positive. And there we go. So it's quite often that, oh no, we haven't finished. Sorry, we found the values of d and u1, but we need to find the value of k such that uk equals 0. So let me quickly write this now that I've found my u1 and my d into my general term. So I have u1 plus n minus 1d. Let me put that all together. So un equals, that was 32 plus n minus 1 times minus 2 for my d. And simplify, 32 minus 2n plus 2. Almost there. 34 minus 2n. So they said, we want to know when uk equals 0. Find the value of k. So that means k is our input and 0 is our output. So we need that to equal 0. We want to find out what the value is there. So setting it equal to 0, we can solve for n, but I should actually write k. Ooh, hello? How weird. Sometimes it has a bit of a moment. It'll catch up with itself in a second. And we can solve that equation. Let's see if I do that maybe. There we go. Oh, sneeze. Let's solve for that. So we have 2n equals 34. So n equals 17. And have we answered the question fully now? Yeah, find the value of k such that uk. And now we found the value of k. Sorry, that's what I was doing. I was erasing it to write k instead of n. So k. So 2k equals 34. And k equals 17. That was a lovely 6-mark question. All right, we have yeah, nothing crazy, but again, do you see the use of attempt? Attempt. So just showing you're working can often get you so many marks, just attempting. So showing them by any means possible, an attempt. All right, another kind of question. The sum of the first n terms is given by this formula. So they've given you the formula already. Notice how it doesn't follow the typical sum one, but that's fine. It's saying this is the formula for getting this arithmetic sequence. P and Q are positive constants. You know what I'm going to say? Highlight positive. So we might get a value of P or Q that's negative, and we need to discount those. It is given that the sum of 5 is equal to 65 and the sum of 6 is equal to 96. So again, we're going to get two equations. So I'm going to take the sum of 5 is 65. So I'm going to substitute for 5 in terms of n. So p 5 squared minus q 5 again, and that's equal to 65. They really love a system of equations in this. And s of 6 is p 6 squared minus q 6, and that's equal to 96. All right, let's simplify these. So I have 25p minus 5q equals 65, and 36p minus 6q equals 96. All right, and we're going to need to solve these simultaneously. What number can I multiply by to get these coefficients the same? Let's divide these all through by 5. So make those a bit simpler. There's many ways to do this, but right, let me first call this equation 1. And I should say, in my different color, I'm dividing by 5. And this is equation 2. Sorry, that's my dog. So then we divided by 5. 5p minus q equals 65 divided by 5. Well, 60 divided by 5 is 12, so that's 13. That's now equation 3. All right, now I'm going to multiply this equation by 6. So I can get it to have the same as this. Again, many ways to solve this problem. Times by 6, I get 30p minus 6q times 6. Well, that is 60 plus 18, so 78. This is more tutorial on simultaneous equations. And then we can take 4 minus 2, or 2 minus 4. Yeah, let's do equation 2 minus equation 4. This also helps you to keep track of where you are, by the way. So 36p minus 30p. Oh no, do we need to add or subtract? Because we have minus 6q. And if we do minus 6q minus, that will make minus 6q plus, which is good. So we do want to minus. 36 minus 30p gives us 6p. These disappear. And 96 minus 78 is 18. Is it? 2 plus 16, yeah, 18. All right, so p equals 3. And let's go and get our q from any equation. I'm going to pick this one. P is 3, so 5 times 3 minus q equals 13. So that's 15 minus q equals 13. Therefore, q equals 2. All right, and we didn't get any negative numbers, just p equals 3. Let me actually do a box around them. P equals 3. And q equals 2. They're both positive, so we're still good. Just double check the question there. Right, so we found the value of p and q. That's a lovely 5 marks. Find the value of u of 6. Now, notice how they say, I'm going to use this color, u6, not s6. So we're not using this formula. We need to find u6. And to find u6, the formula that we have for that is u6 is u1 plus n minus 1 d. And for that, we would need our first term. We have n, and we'd need a common difference. So there's 2 ways to do this. You could either take, because if you think about it, if I take the first term plus the second term, that gives me the sum of the first two terms. If I have the first term, that's the same as the sum of the first term. If I have u1 plus u2 plus u3, that's the same as saying the sum of three terms. So if I want to find u1, I can find that by finding the sum of 6 minus the sum of 5. See how it's only 2 marks as well? So they actually don't want you to go and find the first term and the second term and the difference and everything. You can use this to find the first and the second, and then you can find the difference. So you could find S of 1 and S of 2, and then you'd know your difference and your U1. But it's way easier just to take the sum of the 6 terms minus the sum of the 5th terms, and that's going to give you what is left. Not U1, sorry, U6. So notice that it's only 2 marks for that, and they're often going to do something that you've already worked with. So it's going to be 96 minus 65. Was that what it was? 96 minus 65, which is 31. There we go, a lovely 2 marks. All right, so we have, again, attempt, all these attempts, marks, attempt. Make sure that you state your values of P and Q. If you don't do that, you don't get the final mark. You have to say P equals 3 and Q equals 2. Very important for all questions in general. Oops. And then see, you could find there's different ways to do it, but it was only 2 marks. So when it's like that, if it seems like you're doing too much for how little marks it is, you might be doing something wrong. Okay, so those were a few exam question, past paper exam questions, just so you can see the different ways, because the formulas themselves are easy. It's just substituting, but sometimes they ask it in different ways. So just keep an eye on that. Don't be scared of it. Just substitute into the formula and see what you're left with. And then once you've substituted, you can often see what they're asking you for, or at least just get marks for attempting. There's loads of marks to get for attempting. Okay, so just some exam tips. Write the formulas before substituting the values. I see so many students who don't do this, and then they get the formula wrong, or they substitute incorrectly, or they are not sure how to answer the question or choose the wrong one. So write the formula first. Double check you've written them correctly, and make sure that you've decided, is there a common difference or is there a common ratio? So which of these formulas am I going to be using? Right. There are a whole bunch of amazing notes on Exam Dojo on their page under Learn. So over there we have they have all of the notes that you could possibly need per topic, with loads of worked examples and tips and things. There'll be a homework assignment called Homework Session 14 with some extra questions. And then if you want more past paper exam questions, then feel free to just DM me on Instagram with your email address, and I'll send you all the past paper questions with a mark scheme to practice past paper questions. And there's many different ways which they can ask, but great to practice. All right, does anyone have any questions? I'll just wait for a couple of seconds in case anyone is typing anything. All right, then good luck with all of your exams. I guess there's tomorrow as well. So if you have an exam tomorrow, good luck. maths coming up next week. Hope you're feeling confident for it. There are many other of these videos on different topics if you need to brush up on any topics at all. And if you need any extra support at all, questions, some private one-on-one tutoring, feel free to message me on Miss Ivy Maths or my website, missivymaths.com. And thank you so much for joining, and good luck. Goodbye.